Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where we're going to do something a little different tonight. We're going to talk about P cubed. I know that we do a lot with T cubed. Corey, Tracy, and myself, we're all members of T cubed, so I'm here to learn about P cubed. And I'm so excited that we have Tracy and Corey with us tonight. These two have been in education for a long, long time. Everything from AP readers, sorry, now I know why that's not working. Sorry, they've been AP readers and in the classroom for a very long time, and they are excited to share that with you and their passion for that tonight, as well as I believe their passion for dogs as well is going to come into play tonight. So I'm excited to learn more about that. My name is Mike Houston. I'm the moderator for this event tonight. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. So without further ado, I think, Tracy, let's hear from you and hear about what's on the agenda for tonight.
Okay, for tonight, to celebrate Pi Day, which hopefully you're dressed. I'm dressed for Pi and for Dog Day.
For Puppy Day.
Puppy Day.
Tomorrow, by the way, tomorrow is National Corgi Day.
Yes. And we're going to have 3 activities planned. So we're going to do our best to get through all 3. We've got a Pi Day dice challenge. We've got answering the question, which dog is roundest? And then a pie toss with toothpicks. So everything has to do with pie. And then we threw puppies in there just because. The webinar drawing, Mike, tell us about that.
So if you stick around to the end, you'll automatically be entered to win a free TI graphing calculator of your choice to stick around. Corey, would you mind talking through some things that we hope to be able to do by the end of the webinar tonight?
Certainly. Since I am married to a statistician, she really loves her stats. That's why we were going to do some stuff. So we were going to try to introduce you and dig into the ProbSim app. I know you may have played with that a little bit. And then we're going to look at some scatter plots and some data and do some data analysis. And then finally, we're definitely going to be spending some time on residuals and standard error.
To answer the question, who is the roundest?
And before we dog fight.
No, he's going to do his other stuff.
Oh, okay. Go ahead, Mike. We're going to have the stars show in the background while you tell what you guys say.
Corey and Tracy are getting their props ready. See, I'm trying to do this with a straight face, and I can't. So we are going to be using the chat window tonight to send general messages. If you have any questions for Corey, Tracy, or their furry friends, feel free to use the Q&A window on the right side of your screen. This webinar is being recorded, and we'll provide a link to the event certificate of attendance, as well as a link for the documents at the end of the webinar tonight. So hang tight for that. All right, so without further ado, Tracy, you're going to have to, I think, at least use one hand. There you go. So go ahead and show your screen, Tracy. It's all yours.
All right. Here we go. I'll make sure I get the right screen.
Don't drop the corgi.
I think we just dropped the dog. All right. So tonight, what we're going to do again, 3 activities, and we're going to jump in really quick because I really want to get through all 3 because I think they're fantastic activities. So the first activity that I want to talk about is something I was Googling when we were asked to do something for Pi Day. Of course, we all Google. And I found this activity called Pi Day Dice Challenge. It's from Sarah Carter. She has a webpage, Math Equals Love, which isn't that phenomenal? Math Equals Love. And so I definitely want to encourage you to check out her page directly. But I kind of just like pulled the stuff that I wanted to use to work with. So for this, what you're going to need for your students, you have several options. You can do dice, physical dice, if possible, because your students are going to be rolling a whole lot. If you have foam dice, you won't get a headache. But then the problem with foam dice is they go all over the room and your kids are running around the room. So that's why we're going to be using the Prob Sim app on the calculator to do the dice rolling in just a few minutes. Okay. And so basically at first I was thinking, okay, she touted this as a get a 10-sided die, which I'm one of those weird people that does have many 10-sided dies, and have your students roll all 10 digits of pi. And so let's see.
All 10 digits.
Well, up to the first 10 digits. Sorry, yes, the
Oh
first
my
10
gosh!
digits.
I mean, like, come on. The first thing we're talking about on pi, it's like goes on forever and ever. Kind of like, never mind. I'll be quiet.
Okay. And so to roll the first 10 digits of pi in order, they were supposed to roll the die until they get a 3, then take that die and put it on top of the 3, roll it again till they get a 1, put that on top of the 1. Well, I don't know about you, but I only have so many of these. And I started thinking about what we could do with this data. I mean, that's the kind of the fun part. You can challenge them. Let's see who can get all the first 10 digits of pi first. And I thought, what math can we do with this? Well, the first thing that popped into my head is just the probability of just rolling a 3 for that first digit.
Mm-hmm.
Most students, even if they haven't had a whole lot of probability, know what that would be. Corey, what is the probability of rolling a 3?
That would be 1 out of 6.
Okay. And then what's the probability of rolling a 3 followed by, I have a dash there, but followed by rolling a 1?
I guess it'd be 1 over 6 and then another 1 over 6.
And what do I do in between?
You have to multiply them because they are independent events.
Yes. And so if we want to do a roll of 3 followed by 1 followed by a 4, what would that be?
1 6 times 1 6 times 1 6.
And I know eventually students are going to say, what's a shortcut for this?
1 6 to the third power to the number of dice that you're at. But now, you know, what you have down there below.
Now what I'm doing is I jump to the full 10 because I think pretty quickly they're going to be able to do the ultimate question. What's the probability of getting all 10 the first 10 digits of pi? So what would that be, Corey?
Well, if you're using a 10-sided die for that, then it would be 1/10 to the whatever 10th power is. Yeah.
Yep.
So, yeah, let me get it.
So 1 to the 10 to the 10th. So that's kind of a big number, okay? And we can pick up our calculator and actually see what kind of number this actually is. Let me get this screen out of the way here. And so I can ask the graphing calculator, my 84, do alpha xt theta is a, oops, I got to get out of the history. Alpha xt theta is the shortcut for the fraction template. If you did not know that, write this down. Alpha xt theta, shortcut for the fraction template. 1 over 10 raised to the 10th power. Now, one of the things that I kind of don't like about this on the 84 is it's kind of hard to read. What is that actually? So I would, with my students, say, let's just do 10 to the 10th and look at what the denominator looks like. And so does the same thing.
Yeah.
So there's one little thing with 84 that's like, what is that number? But hopefully your students will be able to actually write that number down as 1 over, and what am I going to write, Corey?
1 with a bunch of zeros after it.
How many zeros?
I don't know, 10 or 11? 10?
8, 9, 10. 10 zeros.
Okay.
Okay. And that's, I mean, that's a lot of zeros.
Yeah.
So I thought, you know what? As a teacher, I'm thinking, how long is this going to take? And after reading Sarah Carver's blog post on this, she's like, this is too much. This was her goal at first, but it's actually too much. So I suggest doing the activity with just doing the first 5 digits of pi in order, because it's much more reasonable and won't take as much time. The other thing, I'm going to go back to my other slide that kind of has like the big picture of everything on one slide for this activity. I decided to change the question because that probability question is, I'm sorry, it's a little boring. Probability is great and fine and we need it, but that's not where my love of statistics lies. So I changed my question. I thought, okay, let's talk about how many rolls of a single die would it take for you to roll a single digit of pi? And I'll tell you why I just decided to focus on a single digit of pi. And notice I have that word on average in front. And so here's how I kind of took her activity where she has the fun part of it, and I needed to add some, I think, fantastic math to it, some statistics that we usually don't do a whole lot with students. I'm not going to get into formulas. Yeah, I could do that with some of my students, but I actually don't want to do that. I want them to see how many rolls of a single digit does it take to roll a single digit of pi. So what we're going to do, and you will find little cards that you can give to your students just like this. And we are going to roll a die. Now, Corey has a foam die because if he would start rolling one of the other ones, it would give me a headache. And so I'm counting one roll.
No, I got a 5. I got a 4.
4.
I got a 2. I got a 3. Got the 3.
So it took him 4 rolls to get a 3. And now he would move to number 1. And now we're rolling for 1. 1.
4. 3. Oops.
Okay, so now this is why we're going to do the prom sim app, because he's going to have that die all over the place. So,
And Blue will probably eat it.
yeah. Foam dice, yes. When she gets her hands on it, she's going to eat it.
Pause.
Pardon me?
Her paw. You said hands. If Blue.
Oh.
Blue doesn't have hands. Blue has
That's
paws.
true.
Very short paws.
All right, so I'm going to use the 84 calculator, and I'm going to use the probability simulation app. And there's a couple different reasons that I love this. If I hit the apps button, I'm going to go up because it's easier. It's quicker to get to the prob sim app because it's 0, and open it up. And you can see your options. We are doing a roll dice. So I'm going to go down to number 2, and you're welcome to do this along with me. And don't worry, I have all the screenshots captured on another slide. So, you know, if I'm going too fast, which I probably am because we got a lot to do tonight, you'll have the step-by-step instructions. And before we do anything, I do want you to know it's set up for what I need. But when apps run, there's these little soft keys at the bottom, and I'm going to just check the setup really quick. So I'm going to hit the zoom button, and that'll select the set. And everything on the at the top left is highlighted, which is what I need. I want just to do a set of trials. I've got 1 dice. It is 6-sided. Here you could do a 10-sided die, but I'm telling you, it's going to take a lot longer if you're trying to do 10 digits of pi. And then I'm just going to leave everything as it is. So I'm going to hit the graph button to select the OK. And then all students have to do is hit roll. And they have this nice little die that rolls and a visual that the roll was a 6. And in the upper left, I rolled once so far. If I click the +1 and tell them only click the +1, roll 1 at a time, we want to wait until Corey gets a 1. So I got another 6, or Corey did. I got a 1. Okay, so now it took him 3 tries to get the 1. Okay.
So she's counting the number of times to get that number in question, not the actual number itself.
Yeah.
So that's always be clear.
And so one thing, if you want to do little tick marks instead of the numbers, I've done that too on my slide.
Yeah,
that might help a little bit with what does that number represent. Then now, since we've got the 1, we want to clear and start again. So if you hit your graph button to clear and say, yes, I want to clear. Now we start to try and get a 4. And so I'm going to keep hitting window until I roll a 4.
Oh, you got it.
Wow.
Wow, you're lucky tonight.
I am doing good.
Oh, no, I'm lucky because you're doing
I'm rolling for you.
Yeah, I'm lucky.
So
I always say she used up all her luck when she married me.
Yeah. So I'm going to clear because I got what I wanted and start again. So I'm shooting for a 1 now. Okay, there we go. 3. That's not bad. He's doing really good, and you'll see why in a minute why I say that. I'm going to clear, and then we're going to get his 5 and then stop there till he gets a 5. 4. Wow. Okay.
There's a question in chat about, did you seed the your calculator before you started the random int? Did you use a seed?
Yes, I actually did. That's actually a really, really good question. Let's escape out of this. And I did forget that. I have that in my list of directions. I'm going to escape out of this. Yeah, clear everything out. On the home screen, thank you so much for reminding me of that. When I went to directions, I probably would have noticed it. There is seed here. If you're in a classroom that the kids reset their calculators a lot, you definitely need to seed. Now, if you don't train them to do that, you know, it still never hurts to seed this application so that each calculator will have its own random numbers. It lets you type in, I believe, a 5-digit number here. Yeah, 5 digits. I just tell them type whatever you want there. Any number you want, 5 digits, and then hit OK. And
I
so
told my kids to like use their birthday or their telephone number or something like the last 5 digits of their phone number. But yes, they should seed it. So Mark, that was a very good yeah. And if you don't do that, then everybody will get the same answers.
Oh, that's a good prank to play on them too.
Yeah, that's
you're first doing random numbers.
So
now I'm going to quit out of this app because that's all I really need it for. Okay. Now this again is kind of like cards that you can make for your students. I have a Google Doc that you can print something like this off. But then what I'm going to do is when they finish, when they get the first 5 digits of pi, I'm going to have them come up to the board and put dots for their number of rolls for each of their digits. So Corey would put a dot at 4, at 3, at 1, and then at 3, and at 4. Now, if you're a smartboard person, there's my steps, okay, for getting into the app. So again, you have all of this right there. If we need to talk about the Nspire, we can. This is my class that I did. This is what I was doing all night last night. I was doing the ProbSim app over and over and over again. And so this is what you would get a class of, let's see, 70 dots, 5 students. So how many people would that be? That would be 5 into 7, 15 students, I think. No, not 15. Whatever 70 divided by 5 is. 70 divided by 5.
70 divided by 5.
12.
12.
Okay.
No, 14.
14. Okay. Sorry. Simple math in front of an audience is hard. So this would be, if you have a class of 14, this is what you would get. Now, the question is, let's go back and read the question. On average, how many rolls of a single die would it take for you to roll a digit of pi? We have a visual, and this is what I love about statistics. We have a visual of this actually happening for 70 repeats, 70 times trying to roll a digit of pi. And my class actually did it. Sometimes they got it right away, a 1. Sometimes it took up to 18. Yes, and I really got 18 twice till I got the digit I was trying to get. Okay.
So you're getting at expected value here.
Yes. So everyone got 5 different possible answers, but on average, what would we expect? This is getting at the idea of what is the center of this dot plot, okay? And getting them to look at something in real life. They actually may be able to answer the question just thinking about it, but I want them to see the visual of this. Now, can they kind of gauge where the center is, just visually trying to balance the dots left and right? Where do you think, Corey, the center kind of looks like it is?
I would say maybe 5, 6, or 7, somewhere in that range-ish, somewhere in there, maybe.
Yeah, I think, and giving a little bit of a range, an area where it is good. It's good enough. Notice we got a bunch of 1s, but we have a couple of really high numbers. We got to balance those out. Now, this is where it depends how far you want to go in the math in this. I actually put this data, because I collected it already, in lists in my calculator. I used list 1 for the values, list 2 for the frequency of those values. I just counted the stuff on my dot plot. And I ran a 1 variable statistics on it. And I have the screenshots here to show you how to do that. And we can see with just 70 trials of this, rolling a die to get a digit of pi, my average, my mean was 5.9. And don't forget to talk about the median. The median was 5. Okay. And so this is where there's lots of different ways you can go with this as far as the math goes, I think. So that's where I wasn't sure. It depends what you're teaching them, how far you want to go with it. But don't forget, it's Pi Day. You're supposed to be having fun too. So even just getting this and having a quick discussion about what the center is, to me, would be a great Pi Day activity.
Yep. And you know, we're like we said, we're going to advertise a lot of, we're going to do a lot of stats because that's what we are now. And besides puppies. So,
okay.
And oh, by the way, these slides are going to be in the tiny URL that we will share after. We'll clean them up, and
yeah,
I don't think we said that, or maybe you did say that.
I think Mike said that at some point.
Okay, but we'll share our completed slides with you after the.
Yeah, and I'll pretty up my writing and stuff. So, and so again, you'll have the screenshots of how I use the 84 calculator. Okay, I think we're ready for the big one.
Yeah, here's our. All right, so we were asked to do this webinar a while ago. It's funny, you may not realize this, but they map these webinars out like what 5-6 months in advance. And we were asked to do Pi Day back in September, and I'm like, what are we going to do that hadn't already been done for Pi Day? And we were trying to rack our brain, and almost as a joke, I said, maybe we can do which dog is the roundest. And we actually put that in our description. We're like, uh-oh.
Yeah.
Is this actually going to work? And so we came up with this activity based on Blue and Holly, and we showed you them before. Here are some of our, we're going to be self-indulgent.
Yep.
Like Mike said, we have been presenting for a while. When he made it sound like we're really old. We're not that old. I mean, well,
presenting for like
yeah, we've been presenting for a while.
over 25 years.
Anyway, we've been presenting for a while, and one of my dreams has been to like literally take my dog to a conference and use it in the presentation. I've never figured it out, but now we kind of did, and we're doing it in a webinar. So our two dogs that are, and we are not body shaming them. We are round doesn't mean fat. Okay. They might be, but that's another story. We're roundest. I mean, it could be skinny or small and round. Okay. But these two are round. So we are deemed that we're not sure which one is rounder. So on the same day, we are big into experimental design. And
gathering data is very important when you're trying to answer a question using data that was gathered.
And you can try to punch holes into our experimental design. That's fine. You can do that in chat, but it's already done. But we would then conduct our experiment. Anyway, so our quality control is that on the same day, we'll measure the circumference and the diameter of both of the dogs in the same locations, if available. Then we'll plot the data separately. And we'll look at the residuals. I love me some residuals. Okay, if you don't know what a residual, we'll talk about that as we go. Then we'll compute the residual standard error of both. Oh, the big deal is we're not gonna run a regression.
Yes.
Okay, this is what really makes this activity like 10 times better than anything I think I've ever done before, that we are going to compare it to a known function. There's no point in running a regression when we know the relationship. And
when we're trying to answer the question of roundness.
Yeah, so we know what round is. We know that round is pi times the diameter. So we're not going to do a residual. Every time I've collected data, the next step is put it in run regression. Then we're going to compute residuals with our known formula and look at the residual standard error. And the one with the smallest residual standard error will be deemed and crowned the roundest. So Holly is the Chihuahua and Blue is the Corgi. And I think we're going to be mostly starting with Holly's data. Okay.
Okay.
So, you want to take it?
So I'll do a little bit.
Okay.
This is my one of my precious babies, Holly. And so we got a good picture of her. This was a very hard picture to get. She is a Chihuahua. If you know anything about Chihuahuas, they're not the nicest dogs as far as they're snippy. And so this is the data that we gathered from her. I'm measuring her with the little tape measure here, around her snout, getting the diameter using a meter stick, or ruler, whatever was easiest at the time.
And we did it from her right side of the body. We did not do it from a top view. The diameters were measured from the side view as they were scanned or as they were in this picture. And then the measurements are there. I don't think you need to write them down. You have them on later screens, so you don't need. Okay. And then we did the same thing for blue, but there was a problem with blue.
Not a problem, just something's missing. Do you notice?
Corgis, not by default, but
many corgis
have docked tails, and
no tail. So
blue has no tail.
No tail.
Yep. So blue has no tail either, and blue is actually a corgi. Everybody thinks she's a miniature Australian Shepherd. She is a blue merle corgi, which is not a common color. Anyway.
All right, so we got the measurements. I'll tell you, blue was much easier to get the measurements from than from Holly. The last couple measurements of Holly, I'm not sure how accurate they are because she was starting to snip at me.
And she was growling. It was funny. It was some serious growling going on. Okay, so if you have your 84 or an Nspire, it doesn't matter which device you do this on. You can do it on either device. You would want to enter this data in Nspire. You'll be doing it in a list and spreadsheet, but in the 84, we'll be doing it in the stat edit.
Now, if you have data in your list, just quick reminder, if you go on top of L1 and hit clear and enter, that cleans up your list. So I'm going to go ahead and clean these up. Be careful. You can bring it back. If you hit delete, that deletes the list from your view. It doesn't totally delete the list. To get that list 3 back, if you go to stat and then number 5, setup editor, it'll bring that list that I made disappear. Okay.
And again, in an Nspire, you would be doing this in a list and spreadsheet, and you could name them diameter and perimeter, or I guess you want whatever.
Yeah.
So Tracy's going to record those numbers into her calculator, and what we're going to do is we're simply entering data, and then we will, after she gets it all in, we will create a stat plot, and then we'll also add the function pi times x rather than run a regression. And that's what I really love about this activity. Even though when you'll see the data appears quite linear, and I could run a regression, and I imagine the regression would probably be pretty close to pi times x, but it would also not be direct variation. It would be like 3.1 plus 0.2. And that's not accurate because a radius of 0 should have a circumference. Diameter of 0 should have a circumference of 0. It has to go through the origin.
And again, we have kind of like a goal equation. We're trying to compare it to something that is round.
Yeah, we're trying to compare Holly and Blue to round perfection. Yeah. So she's going to make her stat plot in a Nspire. You would add a page and do a data statistics page and label it. If you're not in it, if you want us to do this, walk through part of this on the Nspire, I guess we could do blue. Are you going to do Holly in blue and blue?
Oh, I better not.
Yeah, because blue is blue.
Blue's got to be blue. Is red okay?
Red is okay for a child. Yeah, but if we're going to do blue, blue needs to be blue. Okay.
That's true.
Okay. So she's turned on her stat plot for the data and chosen a scatter plot. I'm not a huge fan of Zoom 9. It's like a black box, but for the purposes of this webinar, honestly, I probably would do 0. I would want the 0, 0 to be there. So I might go along the x-axis. 0 to the largest is for Holly was 15 maybe, and from 0 to 50 in the perimeter, but she can do Zoom stat.
I'm going to do Zoom stat. So
there's Holly's data. And when we first did this, we were like, oh, is this really going to work? And then we got the data and I was like, oh, it's pretty roughly linear. Now there's a couple big ones around her chest and her stomach.
Okay. But now is it the right linear that we're trying to capture? Because right now we still don't know.
Yeah.
We need to plot what the goal model equation is.
Right. We're not letting the data drive the model. We're taking the data. we know the model, we're just seeing if the data fits the model rather than the other way around. And that's a twist on every other activity I've ever seen.
Yeah.
So
I'm gonna make this green to just so it stands out.
okay. Although red and green are common color blindness colors, just a common accessibility. Red and green are probably not a good combination, but in this case, it's okay. So they're pretty close.
Wow.
Here in Arkansas, we might say those are dadgum close.
Mm-hmm. Yes.
Okay. Now, close only counts in horseshoes and hand grenades.
We need
But
something
we need
now
some
that will
measure.
capture the error from this model equation, because some of these dots look like they're almost on, probably none of them are right on the line, but some are really close. Others up here in the end, this one's kind of off. So we need to capture the error from the model.
You want to set that screen on here?
Okay.
So you want to, and in case you don't know this, we always do this.
Yeah.
From the Smart View software, did you see what she just did? She just drug the screen from the Smart View into her Smart Notebook software. She could do that into a Word document, a PowerPoint, a Google Slides. You can drag the screen right off your Nspire or your
84
to
emulator to other stuff.
Yeah, and there's a way, like you have to do it from the border on the Nspire, isn't it? Don't you have to like grab the border to do it from the
Yeah, the Nspire, you have to grab the border, not the screen.
Because the screen is interactive in the software. If you grab the border, you can do the same thing from the Nspire software.
Yeah.
So
okay. So now how are we going to capture this error? Let's go look at our data again. Here's our list one, our diameter. And oh, did you notice something? I just noticed it because I looked over at how he labeled the lists. He actually didn't list in the data collection diameter circumference. He has diameter perimeter, because we don't know it's a circle right now. And so perimeter is your general, aroundness. Okay.
Around the corgi.
All right. So how are we going to calculate this, hon?
Okay, so we're going to do the residual. Now, what is a residual? It's the measured value. Okay,
here we go.
Yeah, so we're actually going to talk about the residuals now. And these are huge. I see so many people like to do will do the regression and then get the R value, but that's not all there is to it. You're going to take the measured value minus the predicted value. That's a process. So we're going to take whatever and it's always, and visually, it's the vertical distance from the point to the model. Normally, the calculator will do this for you by default when you run a regression. It finds the residuals, but I want the vertical line distance from that. Now, that one would be positive, right? Because the value is higher minus the predicted value, which is lower. The other one that she's about to draw here, if I took the lower value minus the higher value, I would get a negative residual. So you will get residuals that have positive values or negative values, okay?
And if you're an AP teacher, I know Valentina is, actual minus predicted, AP. I like it.
Yes. So anyway, so what we want to do is we're going to use the list operator. We need to understand this, and I believe these residuals are so important that I think that they should be covered in earlier classes, not just AP classes. So going up onto the column heading, and again, you could use formulas on the Nspire. We're going to take the actual values, which are in L2, right? Those are the
L2, yes.
Yes, because those are our perimeters. Okay, so she's going to do L2, and we're going to pause here, go minus. We're going to take that's the actual values. Okay, the way we have it set up, so it's the actual value minus the predicted value. The value predicted is from the function.
Okay.
So
that's over in our Y1.
That's in our Y1. So we need to tell it to take the list 2 minus the function values. Okay, now, so what we're going to do is grab Y1. If you don't know where that is, it's alpha and then trace.
And that's one of those nice pop-up things that they've got going for
us
now.
I love alpha trace when I'm doing Y1. Now, I can't just say Y1 because I don't know Y1 at what value. So that Y1 is like the function value. So I want to do the function of the diameter of L1 here.
So L1 is where our
The diameters are. So again, we're taking L2, the actual values, minus, and then we're going to use the function value evaluated. I know it's really cool to use the function value or the evaluating functions within a list editor.
Yeah.
Okay. And if she presses enter now, she will get all of Holly's residuals. Again, if you were to run a regression, it would find the 84 or and the Nspire any calculator will, or either of them will find the residuals for you. There's a list called resid. Every time you run a regression, this is done for you. But it's magic for kids. And I think it's important for us to look at this and say, okay, ooh, the first point is above the line, even though that we really can, looks like it's on it, because that's positive. The second point is below, and so on and so on. Okay? Because we can tell the difference between a positive and negative residual. Big deal. And big, we love residuals.
Okay. Now, now, if I'm going to average the residuals, they're going to all add up to 0. So I have a little bit of a problem.
Okay.
So what do we as statisticians do to kind of fix that?
Well, they're not actually going to, they may not add to 0 in this case because we didn't run a regression. When you run a regression,
that's right.
When you run a regression, the residuals always add up to 0. But these residuals, but still, because some of them are positive, some of them are negative, we can't just work with them. So we square them. Now, there is in earlier grades, they do absolute deviation. You could do absolute value, but the statistics property is to square them. So what we're going to do is actually take those residuals and square them, because when we square a negative,
it becomes positive.
Even though the kids forget to put a minus in there. But anyway.
So I'm up at L4 and I'm doing second 3. You see how I'm getting that list 3, list 1, 2, second button, and then the numbers? And then I want to square it. So it's taking everything in L3 and squaring those values. Okay.
All right, now we need the formula for residual standard error, which I think you have on the next page, don't you?
Yep, there it is.
Okay, so do you want to, you're the statistician.
Okay, so what we've done so far, if you think about in our list, is we have these values right here, okay? We have the actual minus the predicted, and we've squared them. So we're going to have to come up with one value to measure Holly's roundness is the way I'm looking at it. We know she's not completely round. All her dots were not on that model equation. They were off a little bit. So we're going to grab all those offness and kind of capture them as a single value to judge her. And so we're going to add all those values up, then divide by degrees of freedom. That's kind of the statistics way of saying your sample size minus 1. Okay, and then we're going to have to undo the squaring by taking the square root. So your residual standard error is kind of, I describe it to students as like the average of your errors with a little statistics twist to it. Is that good, hon?
Mm-hmm. Because the measurements, when they're positive or negative or above, they're not round. Okay, she wasn't round ever, but she was close. But this is kind of a, so if we, sometimes she was more, sometimes she was less, whatever. But if we take those errors and not worry about sign, this is a way of measuring them.
Now here, don't make the mistake like I did many times when I was doing this. I'm just calculating a single value. So I'm sitting in the first cell of list 5. I'm not going on top like I've been doing a lot. And I need to add up everything that's in list 4.
I usually do this in home screen, but
I like having it right here by all my data. Yeah, I guess that's why I like it. So I'm going to do second stat to get my math that I can do with lists. And one of the maths that I can do with lists is sum them. And I'm summing up L4. And then I'm going to divide by, what am I dividing by? There were 8 measurements, right, so I'm going to divide by 7. Okay, now I'm still going to have to do a square root, which I forgot to put in here.
Oh, your favorite thing in the world.
Yeah, well, I'm thinking it's not going to work though. If I do second delete is the insert button, I could get my square root in there. Yeah, it doesn't put that in there though. I don't know. Yeah, I keep messing that up. So I gotta do my square root first.
You've got
and then I'm gonna do it again.
Stat and then over to math. And then number 5, same.
And then list 4, and I'm dividing by 7. And I could use the fraction template there too if I wanted, but I need a decimal value. I get a decimal anyhow. 2.684. So that's Holly's roundness score. All right. So we need to do blue, right?
Yep. Now, you do have...
Yeah.
20
We don't have time to do blue.
Well, you have 20 minutes if you want to do a little bit in the Nspire.
Want to do a little bit?
You want to try to do a little bit in the Nspires? Or do you feel like...
I don't know. Let's go through this one again. Someone wants to do this one again.
Okay.
So up here, I'm going to go ahead and clear this out and double check this. Tell Holly it sounds like a big number. Oh no, we'll see. So if it's a big number, that's good. That means she's not round, right?
Yeah, the smaller that number,
Yeah.
the more round she is. And I've always compared Holly to like a salami because she's like this, the same roundness all the way around. And so anyway, it's good to know she's actually quite round.
Yeah.
So let's do that calculation again.
Yeah.
Yeah.
So I'm looking at my formula. I'm going to remember now. I'm doing the square root first. So I'm doing second x squared. Underneath the square root, I want to sum. And then what I had circled was my values in list 4. So to get your list math, the math you can do with lists, if you hit second stat and then go over to math, number 5 is summing list, the ability to sum list. Look at all those other things you can do with lists of values.
Mm-hmm.
Kind of nice. One variable statistics if you just want to focus on one thing instead of doing the whole thing. And then I'm summing up list 4. And then I'm dividing by the degrees of freedom for Holly would be 7. Degrees of freedom for Blue will be 6 because she had 1 less measurement value. Okay. Again, we will have screenshots of where to find all these things too, because I know sometimes going back over what area to look under the calculator is sometimes hard to remember.
And so what we're doing is, and we're still comparing to roundness, but we really like this because we're pulling the black box off some of the residuals and some of the stuff you get with the regression and really talking about the statistics. But I also think it's really important. I mean, you maybe don't have to get into the residual standard error, but you should be looking at those. You could, with younger kids, even in like an algebra class, you could look at those residuals and just do the absolute value of them and try to find the smallest. There's, what is it called? The mean absolute deviation is another way of doing this. It would have been more appropriate for younger kids. Okay.
Oh yeah, someone said you can use the dim of list 1 minus 1 as the denominator.
Mm-hmm.
Yes, to calculate your degrees of freedom if you forgot how many measurements you had. Awesome.
Yeah, and
awesome.
the degree of freedom is actually the number of points minus the variables. In this case, it was only one variable. But if you were doing a 2-variable regression, it could be -2, or so. That's why it's not always just n minus 1. That's the degree of freedom, but that's beyond AP stats.
Yeah. Okay, so we would want to do this exact same thing for Blue to capture her value. Now, one of the limitations on the 84 is when you're doing your lists, you only have the standard L1 to L6. Yes, we can go over and do some named lists. If you go on top of L6 and move beyond, we could actually create our own lists and have both data on the calculator at the same time.
Yeah.
Okay.
Oh,
and let's do that for looking at her data as comparison.
Okay.
Okay. Since we've got a little bit of time to do that.
You do have, well, you only got 17, 14 minutes.
So I'm going to pop her data in real quick.
So again, she went up to now she's got to name the list.
Yeah.
So when you, in the 84, when, like she said, she went up to the column heading, went over to the right, and then there are new ones. So she could call this A and B, or
I'm just doing A and B.
it could be, BD for blue diameter and BP for blue perimeter. Okay. So we're going to use the same thing. And the cool thing is you can save all of this data as a set. What do we call it? It's a group, right?
It's a group.
you can make a group of the data and save it to pull up later. But on your emulator, there's also the ability to save an emulator state. I don't know if that's which way you were going to go with it, because she has data. I think she has
I have it
blue
in a
already
group.
done.
Yes.
And she's going to show you how she could have done this much faster. But because we have a little bit of extra time, she might go through the calculations again.
No.
No? Okay.
I really want to see the picture blue with Holly.
Okay.
To see if from visually, can we see is blue
less
round or more round?
Okay. So I get you. So now we're going to make the stat plot. So we're going to put it on the second stat plot, and we're going to make it blue because
it's blue.
But she's got to do list A and list B. So where do you get a named list?
Now, when I get the named list, I do second stat for list, and that first option now has the list that I just created, A. Okay. So you don't have a shortcut for that.
So she made named lists that weren't very meaningful. But
yeah, just because.
And you see, she actually was doing something with resid there before.
Yeah.
So now we're going to change that color to blue. I'm going to insist on that.
And then I'm just going to hit graph.
Don't you need to do zoom because blue's a little bigger.
Blue is a little bigger.
Yeah, zoom,
she might have some dots
yeah,
out further.
Zoom stat because blue is bigger than Holly.
Yeah.
So now that's interesting. You can compare, and it did seem like the bigger measurements tended to be around their chest and their stomach. So blue is a little bit pudgier and a little bigger than.
Yeah, I'm seeing like 2 dots here that are higher.
Yeah.
Than the model line.
But the other 5 seem to be pretty close.
Yeah.
That's a pretty cool visual too of the 2 by comparison, compared to the actual roundness line.
Yeah. So let's go ahead and come up with, I would go through and do blue's numbers just like we did Holly's, but for the sake of time, let's try and, someone said about the hair. Yeah, blue is definitely fluffier than Holly. I tried to do it tight, but she growled a little bit when I squeezed her stomach. So what I'm going to do is I actually saved, as Corey was indicating earlier, my lists and the Y1 for blue in a group. Now, I don't know if you've used groups before, but it's a way you can package things together to open up later. So if I go to the memory, second plus, you may have never noticed this before, but down on the bottom is group. And this is where you could create a new group. Now go to this just so you can see what you can package as a group. And I'm just going to give it a name. Oops.
Oh, you have to go.
Shortcut group.
You're already in alpha.
I'm already in alpha mode. I always forget that. And so I'm just going to give it a name. And notice I'm going to go ahead and select the all. So you can see you can group lists. Those are all lists. Matrices, equations. If you have more than Y1 in there, it would have all of them there.
Programs.
Your window settings.
Yeah.
Yeah, a whole bunch of stuff that you can group together.
So it lets you save everything, and this is how it would work on a physical calculator. You can save where things are the way, and then what she's going to do now is do an ungroup.
You can see I saved blue and Holly just in case something happened and we goofed up Holly. We could pull her information up too. But we're going to open up blue. Now it says you already have stuff in your list 1, list 2. Yeah, because that's all of Holly's stuff, and I'm going to overwrite it all. So I am losing Holly's information. But now if I do my zoom 9, you can see I only have blue and my model equation. What we're really interested in is the lists where I did my calculations for the residuals.
And Mike was right. It does look like blue had, or Holly had a pretty small number. Blue's number comes out to
3.4727. Let's put hers on there. Where is it? So blue is, and I better use blue, right? What was it?
3.4727. I think.
I can double check that.
Yeah.
Too many screens going on here. Move this where I couldn't see it. 3, yep. So who is more round? What does that mean?
means Holly, and Holly is more round. That doesn't mean she's bigger or fat. We're not body shaming him. She's just rounder.
More round.
She's just
she has smaller error
in her roundness.
Put in her roundness. So Holly is the winner. Okay.
All right.
So you will have the data if you want to use our data with your kids. Use your own dog's pictures. We don't care. Or bring your dogs into school.
Yep.
Now, Ann asked, rounder as opposed to another shape like oval.
Yeah, we do have actually 7 dogs, and there was one dog, a really big dog, who's got a very broad chest, who is very oval-like.
Yeah.
We totally opted him out because he's not round at all. These two are not fat; they're just round. They're mostly round around their whole body. Anyway, so. But again, don't get caught. I mean, it's cute and we like the dogs and everything, but I really love the idea that we're talking about models without a regression.
Mm-hmm.
And that's kind of a nice thing about this activity. I hope you enjoyed that.
Yeah. Share that with some of your colleagues who don't do regressions with kids. It would be awesome if they could have this kind of experience before running a regression. My kids jump to that immediately. Even in AP stats, they jump to regression without stopping to think first. So that's why I thought this.
Yeah, it's always really good to look at the data, look at those residuals before you ever do anything magic black box. Okay, you got about 6 or 7 minutes?
Yeah. So the last activity that I have for you, this one is not calculator based except for dividing at the end. So I found this one on Exploratorium. So the website is there. So if you want to go read all of it, there's actually a whole lot there. If they have the reason for it, the math reasoning for this. Again, Pi Day, let's have some fun. And this is let's do a little bit of an activity and see pi jump out of it, okay? So pi is so many places that you might not have noticed it before. So here's the activity. It's called, you're going to be dropping toothpicks. They say randomly tossed, but you're really just dropping them above a piece of paper. So for this one, you don't need a whole lot of stuff. I know we have toothpicks galore in our junk drawer. So you need a piece of paper, a ruler, pencil, and toothpicks, and that's it. And you don't even need, a graphing calculator. You just need a small calculator because there's just one division. So what your first job is, the assembly part, is having your students take your piece of paper, draw 2 parallel lines. Now the key is make sure the distance between those parallel lines is exactly twice the length of a toothpick. So what I did, and I tried to mimic this in Smart. So when I'm demonstrating to students how to do it, I mean, I would love to have my little camera here, but that was a little bit too much. Here's my piece of paper over on the left. Okay, that's that box supposed to represent the paper. And I have two toothpick widths, and I'm drawing parallel lines. So how can we get students to do that? Lay down, especially to get them parallel, lay down the 2 toothpicks, draw dots at the end. So I'll try to do my best to draw a dot with the toothpick, and then there's another toothpick and draw a dot, and then do it over at the other end of the paper. And I mean, parallel doesn't mean it has to be straight up and down. It could be tilted a little bit. And I'm thinking this will still work. They didn't say anything about that. Maybe I need to try that, but at least it'll be as close to parallel if they do it that way. Okay. And so there we've got our 2 parallel lines on our piece of paper. Then what we do, I'm trying to get these guys off here. Then what we do is we toss toothpicks. So pick up a toothpick at a time and just drop it onto the piece of paper. And so again, trying to mimic this using Smart, I have some toothpicks over here. Some are tilted. They are not guaranteed to be the same size, and they're cloned infinitely. So I can toss them over. Come on. Toss them over. Why is it not? There we go. Oh, that one missed the paper. That's okay. Let's get this one to toss over. Let's get this one to toss over. So I'm just tossing. I'm going to do this for a while.
Now you could drop like a box of them, or a handful of them at once, and then
My kids are going to be told to do one at a time.
because she's so mean.
Why can't I grab this one? I've got someone at my shoulder. This is much easier on a smartboard. I mean, I'm just tossing them and they're just falling all different ways. When can I stop? Now, when you're tossing them, I mean, they're randomly just kind of going all over. Wherever they land is where they land. Where is pi? First of all, make sure once you have them all tossed, take away the toothpicks that missed the paper or poked beyond the paper's edge, okay? And for me, that's telling my kids, get rid of those, okay? So I'm gonna get rid of the ones that are poking over the edge of the paper. Those aren't gonna count. What you have left, and we're gonna say this one is in there. And what you have left is you count how many touch or cross the line. So that would be 1, 2, 3, 4, 5, 6. I see 6. Do you see 6?
Yeah.
Okay. 6 are touching across the line. And then how many did I toss total? So I'm going to count the ones that aren't touching and add 6. 3, 4, 5, 6, 7. So 13?
Yeah, 15.
14. There's one I missed. I'm going to say 15, go along with what you said total, or with the 6 added on.
15. I think, yeah. I think I counted 15. 15's good.
Now, you definitely would want to do this more than just 15 toothpicks. I mean, I know I have those extra 3. Statistics, many times you're going to be approaching a value. So if you divide these, this should give you your approximation of pi. So I get 15 divided by 6. So this is like I'm finally picking up my calculator. I'm dividing 15 divided by 6. Do not use the fraction template here because you want the decimal. If you do the fraction template, a hint to force it to give you a decimal is to put a decimal by one of the integers, and then it will give you the decimal. Now I get 2.5, which I know is not close to pi.
But you didn't do it.
But I hardly did it at all.
15 is not a large sample statistically, but we wanted to give you a sense of the activity.
Yeah. And so, the decimal works on the Nspire too. I love that.
And why does that work is the default is always to give you a fraction if it can, but once you tell it decimal, you're saying I want approximation, even if you didn't give it like 6 point or 6.0. As soon as you put a decimal, you're telling the calculator, give me decimals back. Decimal in, decimal out.
I think he did add the 6 to it. So I'm thinking there's 15 things there.
That's a shortcut for when kids need a decimal.
And you're not supposed to count the ones that missed the paper or poked beyond the paper's edge. Okay, so that's why I threw those over to the side first before I started my counting. Now, if you want a really good sit down and read about why this is working, I mean, if you kind of think about it, it sort of makes sense because of how you're splitting the paper. But this website actually goes into a very deep discussion about the whys behind this. So again, it's just an activity for students to see pi in a place they would never expect it.
And so that's what we were looking for. Remember, we wanted to do something different than the typical Pi Day webinar. So, Mike, I think we're done. And if you want to close up shop and do your drawing and all.
Sounds great. Thanks, everyone. So as promised, we are going to be giving away to one lucky winner a TI graphing calculator of their choice, and tonight's lucky winner is Wanda Delval McLeod. So Wanda, congratulations. We'll be in touch over email next couple of days to get some information from you, but start thinking about which graphing calculator you're going to choose. To receive a certificate of attendance, go ahead and click the link in the chat window. And I know that a lot of people are looking for the link for the activities from Tracy and Corey, and they can post that tiny URL in the chat window. But if you missed that, you can also get it from the documents link that I posted. I posted a link there as well. So lots of links flying in the chat window in case you miss any of them for any reason, whether it be the chat, the documents, the certificate, sorry. That will all be included in a follow-up email in a couple days, which will be a link to the recording so you can watch this again at your own pace, a link to the certificate, and a link for the documents as well. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. When you leave the webinar tonight, a brief survey will automatically appear in your browser. We really value your feedback and your support. So if there's things that you like tonight, let us know. If there's things that you wished that Corey and Tracy would have done differently or better, let us know that too. We'd love to hear your thoughts in the post-webinar survey. So huge thanks to Corey, Tracy, Blue, Holly, everyone that participated in the webinar tonight. I've been doing this for a long time, and I've never had any four-legged people on the webinar, so this is the first for me, but it's always fun to try something new. So thanks so much, everyone, for playing along with us tonight, and have a great upcoming Pi Day. We hope to see you back online next week. Have a great night.
Good night.
Good night.